names are my name is Chisola Nyala. I'm a recent graduate. Did my bachelor's in India. Yeah, bachelor's in electrical engineering. Yeah, I came in July. So since then, I haven't really worked, but I've done a bit of freelancing in solar designs. So today, the presentation is about solar system sizing. So we'll be looking at how to design a solar system. Yeah. So what we look at in the presentation. So basically, we'll start with why solar solutions. Why would one go for solar solutions? Then also look at the trends in the technology and just general parameters that are very important when it comes to solar design. Then from there, we'll go to the design steps. Then finally, we'll look at the solution evaluation. That's where now you have to evaluate the design that you've made, whether it's worth it's worth to actually be designed or not. Does it meet the cost, or do you need to make some adjustments? Then we'll conclude from there. So let's get started. So yeah, some trends in the technology. So basically, solar has been there for quite some time now, but it has had its own challenges. For example, when you look at the material cost, it's very expensive to process silicon. So due to the material cost, we find that the industry has been struggling for some time. Also, the issues of weight, like there's a limit to how much panels you can put on a house. So that limits the capacity that you can actually generate to power the house or whatever, or the industry, or whatever applications that you're using. Then there's also the issue of space, land itself. Yeah, so there's so much research that have been going on to try and overcome these challenges. So when you talk about the recent trends in technology, we are talking about things like we've seen they've been able to make floating solar farms. This has come about to overcome the challenge of land or space. So we now find that there are plants, put or over seas or water, something like that. So this has really come in handy for the industry. Then we also see things like the BIPV, in short, the building integrated photovoltaic systems, which are also coming into the technology. Things like the solar roofs that we've seen. So these are some of the things that are happening in the industry, and of course, there's solar fabric going on. So when we talk about why we go for solar, basically we are going for solar because of its flexibility in the nature of electricity that we get. For example, I'm talking about it can be grid tied or it can be just off grid, and then it's also modular. In short, I decide how much power I want to generate in order to fit my capacity, or rather my cost that I have. If I just want power for lighting, I can do that. If I want power for other applications, I can also do that. So it's a bit flexible and modular in nature. So it's also, we know it's renewable. In other words, I know that the sun is somehow guaranteed tomorrow. So these are some of the advantages of solar. Solar. Then we are also talking about, there's no need for transmission lines. You generate just within your space. So there's a cost that is minimized when it comes to transmission. Um, then just the general parameters that one would really want to consider when it comes to the solar design. Uh, you want to look at the component material. In short, the batteries that you're using, or the solar panels that you're using, what kind of materials are you using? Because the material will determine the efficiency and the performance of the system. Yeah, so in general, you want to also look at where are you going to set up the plant. That's why we're talking about the location. How much sunlight is available there, because that's a very important parameter when it comes to design. You want to have the panels, in a location where they can receive direct sunlight. Then you also want to look at certain constants, like the peak sunshine hours, and this has to come with location. The average, intensity of light that you get in 24 hours. Then other factors also, like the panel generating factor. This has to come with the type of panels that you're actually using. Then you also want to see where are you going to put your system, or what's the application of the system? Is it going to be mobile, or is it going to be just somewhere fixed? So those are some of the parameters that you want to look at before you even begin designing the system. So having said that, I think we'll dive into the design steps of the system. So the first thing you want to do when it comes to designing a solar power system is the load calculation. So in load calculation, what you really want to find out is how much load does the client want to power. So how much load you have will determine how many panels you actually need, or how many batteries size you need. So to do that, you will make sure you list all the components, rather the appliances that the client has. Then you get all their power ratings and find the total. So after finding the total power for the appliances that you're using, you also want to find the energy, or rather the rate at which the power is being used, rather energy. So the energy, you will actually have to do it according to the appliances. So for example, if you have a TV, you want to look at for how long will the TV be on using the solar system that you're designing. So you have to multiply the power with the hours of operation for that particular device. Then after doing that for each device, you want to add all the energies together to find the total energy in watt hours for the system. So after you've actually done your calculations, you now want to size the system. So the first thing you really want to actually look at is the inverter, because the inverter is one of, I would say it's the heart of the system, because some of the, when you go on the market, selecting an inverter can be a little bit of an issue. So you have to make sure you have an inverter before you proceed with the design. So how do we actually select the inverter? So the inverter that you select has to be able to handle the power capacity of the system. So what you do is you already know the load in terms of watts, or the power itself. So that power, you have to give some allowance, because you don't want to burn up the inverter. So in short, a safety factor, for example, in this case, I'm getting a safety factor of 20%. That's the reason why I'm actually multiplying by the factor of 1.2. And then the K is the inverter efficiency, because the inverter may not be 100% efficiency, which is almost impossible. You can't have it you can't have it to have 100% efficiency. So you want to consider that as well. So if you know the inverter efficiency, and you consider a factor due to losses, in this case, I'm using the 1.2 factor, you will then use the formula to make sure you find the inverter size. Then the other general things you want to look at when you're actually selecting the inverter, the continuous power rating, the same one what we've just calculated, that's the continuous power rating. And then you also want to consider the surge power rating. For example, you also need to look at the applications of the system. If you've got loads like motors, then you might want to increase the factor a little bit higher than 20%, because some loads really have initial high current, so that may damage the inverter. So you look at the specifications of the inverter. You want to look at the continuous power rating, the surge power that it can actually handle, input protection. So I'm talking about input protection. I'm talking about what does the inverter do in case it receives overcurrent. So does it protect itself? So those are some of the features you want to look at. Then when you look at the output protection, what happens if there's an overload? If your system is drawing more than the capacity of the inverter, what does the inverter do? Then also the frequency of operation for the inverter. Then connectivity, basically you want to look at the features of the inverter, like what does the inverter have? How can you monitor the inverter? Does it tell you how much voltage, how much current is flowing? So those are some of the things you want to look at when you're selecting the inverter. Then I think for the inverter we are done. And then the next thing you really want to size is your battery system. Now for the battery, you want first of all to decide whether you want to have a backup or not. So if you want to have a backup, you want to ask how many days can I have backup? And when I talk about backup, I'm talking about autonomy. Autonomy is basically the number of days the system can go without generating. So for example, if you've fully charged your batteries today, the question is how long can it go without charging it again? That's autonomy. So you need to decide the autonomy of the system, and then so for us now to find the capacity of the batteries in terms of ampere hour. So basically, you want to convert the energy that you initially calculated into ampere hours. Then we do that using the formula here. So you know the energy, you multiply the energy by the days of autonomy, then you divide that energy with DOD, or rather the depth of discharge multiplied by the system voltage at which you are operating. So this will give you the capacity of the batteries, in short, the total capacity of the batteries. Then to know how many batteries you want to actually have for the system, you just have to divide that battery capacity with the capacity that each battery has. So that will tell you the number of batteries that are required to sustain the demand that you need. Then some of the parameters you would want to look at when you're actually even selecting the battery is what we see here, the depth of discharge. So the depth of discharge basically tells you how much of the battery are you draining off. So practically, ideally, the best depth of discharge is supposed to be 1. That means you have a battery which you can fully discharge and charge again. But most of the batteries have lower depth of discharge. And in that case, it means if you are discharging the batteries to as deep as you can, the number of cycles actually reduce. It means the lifespan of the battery reduces. For example, if you are discharging your battery, in this case, when you look at this diagram that we have, if you are discharging the battery at 30%, you discover to say it gives you something like 1,200 cycles. So that means to know if you are discharging the battery once in a day, so we need to divide that number by 365 days to know how long the battery can actually be sustained. So the lower the discharge that you are using for the system, the longer the batteries will stay. After that, yeah, let's move on to the next component that you want to actually size. So after you know your battery capacity, you also want to know now how much panels do I need to charge the battery that I have, and also the size of the charge controller that you need to protect the batteries when you're charging them. Yeah, so the parameters you want to consider are the peak sunshine hours, of course, and then the panel generating factor as well. Then you also want to put a safety factor, because there are losses within the system. So you want to account for the losses to make sure that you have enough power to the system. And so basically, for us to find the panel capacity, or rather the power that we need from the panels, we'll just have to divide the energy, the total energy that we initially calculated by the peak sunshine hours divided by the safety factor of 1.3. So this factor is subject to research. Yeah, but this 30% mostly works for the designs. Yeah, so in Zambia, I think the peak sunshine hours are within 5 to 6. So you want to use that figure when you're doing your design. And then, yeah, so how do we select the charge controller? So for the charge controller, you want to actually be, very sensitive to its current rating, because it's about how much current it can actually hold from the panels. So now that depends on the number of strings that you have, So if I have, for example, 4 panels, then I've actually had, I'm actually putting 2 as a single string. Then I have 2 strings. That means I need to multiply the short circuit current for each panel, which will be the same for each string, and then multiplied by 2. So if I only have two panels in series, that means I have a single string. So the short circuit current for one panel will be the same as short circuit current for the entire string because they're in series. So that has to be satisfied by multiplying by a safety factor of 30% to know the size of the charge controller that can handle the current that is coming from the PV array. So that's what you want to do when you are actually sizing the charge controller and the panel. Then that's much of the sizing. Those are some of the parameters that you really want to consider when you're doing the design. So the designs are different because they also depend on the configuration of the batteries, configuration of the panels, whether you're putting how many panels in series, how many panels in parallel. That affects, for example, the cable size for the system. Because if you're putting panels in series, that simply means you're increasing the current. So if the current is increasing, that simply means you want to have higher size cables so that they can withstand the amount of current that are coming from the array. So those are some of the parameters you want to play around to make sure that the design is fully functional and safe for the system. Yeah, so those are some of the things that you want to do. Then you also want to look at the capital cost as well. Does the client meet the cost for the design that you've actually designed for them? So yeah, so you do the analysis. Like I said, the battery configuration, how does it affect the cost? Basically, it affects the cost on the cable size and other things. So you want to look at that and find the compromise between cost and the performance of the system to just make sure there is a balance between the two. Yeah, and then you also want to yeah, you also want to look at your analysis in terms of the type of batteries that you're buying, because that affects the cost that you want to actually put in place. Then also, yeah, you also want to. So basically, when you play around this, you play around these parameters. You just want to see if the cost can actually be met to ensure that the client gets a system. But even as you are playing around with these parameters, you don't want to affect the performance of the system. So safety comes first, and yeah, so basically that's how we size the system in a nutshell. But I've just seen that some people have just joined. I'm not sure if you can actually. I'm not able to get your feedback, but I would be glad if someone just talked to me, because this is just a summary of how you do the design. I hope everybody can hear me. Yeah, I've seen Abel, you just joined. Yeah, so I've actually gone through the presentation. I hope I can. I'm trying to. Yeah, you can just shoot me a text. Otherwise, that's how we design the system. But I can go through the entire presentation again. Okay, for the sake of Abel, I'm going to pass through the presentation again. I'll try to be as quick as possible. Yes, so the presentation is about how to size the PV system. Okay, yeah, I think this is Abel. Yeah, so I'm going to start. I think the other one has left. So yeah, so I'll be talking about how to size a solar power system. Yeah, and in this we'll look at why solar solutions, then some trends in technology, then also look at general parameters to consider before you actually design your system. Then from there, we'll go into the design steps for your system. And then after you've done your design, you want to evaluate the design or the solution that you've actually come up with. Is it feasible? Is it tangible? Does it make a difference? I mean, does it make sense? Does it meet your cost or your client's cost? Yeah, so let's get started. So you actually, there are some trends in technology, and these trends have come from the challenges that the industry has had for a long time. So the solar industry has been there for quite a long time, but it has some a lot of challenges. That's the reason why it's not really that utilized by most of the people. And some of the challenges we're talking about is the weight that comes with the panels. So the people try to design to make sure they have minimum weight, but there's always a limit to how many panels you can actually put on your roof. So those are some of the challenges. Then there's also challenges of space or land. There's limited land to put up solar power plants. Then material cost. Silicon processing of silicon is one of the most expensive processes when it comes to manufacturing. Then research as well, how much people know about the technology, is another thing that has been of the challenge. But these are some of the things that are, a lot of researchers have been working on, and we see now people coming up with things like the floating solar farms to solve these challenges. Then we also have things like the BIPV, which stands for, building integrated photovoltaic systems. And then you also have solar fabric coming along. So these are some of the trends that are going on in the industry. Then why solar? So basically you want to go for solar because it's clean, it's long lasting, that it's actually guaranteed to say tomorrow somehow the sun will come again. So these are some of the advantages why you want to go for solar solutions. It's modular. In short, it gives you freedom and control over electricity. For example, if I just want to have lighting in my house, I can just do that. But if I want to include a TV as well, I can do that. It's modular in nature. It gives me the flexibility to how much I want to generate for myself, meeting my demand, or rather my cost, my capital, or how much I have. Then it actually gives you almost zero transmission cost because the generating point is actually almost the same as where you actually want the electricity to be. It's pollution free. So that's some of the advantages why we want to go for solar solutions. Now, having said that, let's just look at the general things that you really want to look at before you actually do your design. So you want to look at the material type. For example, what types of types of solar panels are you buying? What material are you going for the solar panels? Because that decide the efficiency or the performance of the system. Then the efficiency in general, the efficiency of the inverter, the battery, the panels. You also want to look at those parameters to make sure that you have a very healthy system. Then another thing is location. Where are you going to install your solar system? You want to look at that. Then you also want to look at certain factors like the peak sunshine hours. How much of sun does Zambia receive? You want to look at that factor. Then you also want to look at the panel generating factor as well, which depends on the manufacturers as well. Then you also want to look at where are you going to put your system? Is it going to be a mobile system or it's going to be a standalone somewhere fixed? So that also determines the design and whatever you're doing. Now, having said the general things, I want us to dive into the steps of how to actually size your system or design your solar system. So we'll start with the first thing you really want to do is the load calculation, because you want to know how much load are you powering. You want to actually know how much of appliances need electricity from solar. So the first thing you do is you list all the appliances that you want to power with the solar power that you're designing. When you list them, you also look at their power ratings. Then you find the total power that you have from the load. Then after that, you also want to find the energy consumption. In short, if there's a TV, for how long will the TV be on? How much of power will the TV be using in 24 hours? So you want to multiply each power rating with the operating hours. Then you want to do that for all the appliances and find the total energy in watt hours for the system. Then after you've actually done that, you want to size your inverter. So how do you size your inverter? So you already know the total power. You already know the total power that you've calculated from the load. And how many watts do you have of the appliances? So that total power has to be handled by the inverter that you actually select. So you find that the inverter is more of the heart of the system. So the total power that you've already calculated must be multiplied by a factor, something we call as a safety factor, because there's loss between between the load and the inverter. There's cable loss in between them. So you want to ensure for that as well. So you multiply that by a factor of 1.2 to say 20% safety factor. Then there's this factor, the K here. The K is basically the inverter efficiency, because it's not practical to say the inverter is 100% efficient. So if you know the efficiency of the inverter, you just have to put it there, and it has to be in form of the factor. If it's 80%, then you need to divide that by 0.8. Yes. Then other things that you want to look at when you are selecting your inverter are the surge power rating. There are some applications where you're using, for example, motors. Motors would initially draw a huge, amount of current. So you need to protect your system, or rather your inverter, from such. So you need to select an inverter with high surge power rating so that it can be able to handle the initial surge power that appliances may have when you switch them on. Then you also want to look at the input protection features for an inverter. So the input protection features are basically how does the inverter behave when you're feeding it with overcurrent? How is it protected? What does it do? Does it have a feature to protect itself from overcurrent? Yes. Then you also want to look at output protection. Now, output protection is basically what happens to the inverter when you're drawing more than its capacity. Then you also want to look at the frequency of operation and connectivity for the inverter. So connectivity basically is an option that shows you how the system is behaving. So the inverter does have a feature to show you how much current, how much power you're generating at the moment. Do you have a monitor where you can see those things to monitor the entire system? So those are some of the things you want to look at when you're selecting your inverter. Now, after you've selected your inverter, you want to actually size your batteries. So you are going to battery sizing. So the first thing you want to select when sizing your battery is the autonomy of the system. So autonomy means backup. In short, if your batteries are fully charged right now, you want to ask yourself to say, how many more days can they go without being charged again? That's the autonomy. Yeah, so you want to select your autonomy, and then you want to find out the battery capacity in ampere hours. So how do we do that? We have this formula here. So we use the formula here to find the battery capacity in ampere hours. And so you already know the total watt hours or energy from the appliances. You have to multiply that by the days of autonomy, then divided by what we call the DOD, or rather depth of discharge, multiplied by the system voltage. No, that is going to give you the total battery capacity for the system. Yeah. Now, for you to know how many batteries you need, you just need to divide this battery capacity divided by the single battery capacity. So if you're having 200 Ah batteries, you need to divide this capacity with the 200 Ah batteries to know how many 200 Ah batteries are required for your system. Yes. Yes. Then you also want to look at the depth of discharge, because if you are discharging your batteries at a very high rate, then the lesser the batteries will actually stay. Yeah. So after your battery size, you've sized your batteries, you want to finally size your panels. Yes. So this is what you do. So you consider the peak sunshine hours uh, and the panel generating factor in order for you to. So that's the thing. So to find the total capacity that you need from the panel, you want to multiply the energy that you initially calculated by a factor, a self factor. For in this case, I'm getting 30%. Then I'm dividing that by the peak sunshine hours, which depend on the location. For Zambia, it's within 5 to 6. So if you divide that, you know how much how much energy your panel needs to provide. Then you can actually find out the number of panels by dividing this capacity with the power rating for a single module that you're using. Yes. Then yeah. So after you've done your sizing and everything, you want to do what we call capital cost comparison and a few adjustments, because sometimes you might do the design, but the cost is very high, such that the client is not able to to meet the system that you're asking for. Now, how do you minimize cost? You want to play around with maybe battery configuration, solar panel configuration, because these affect actually cable size and number of batteries that you need. So you want to, find compromise on autonomy. You want to do an analysis on the type of batteries that you are using, because they will definitely determine, how good your system is. So you want to play around these parameters to ensure that you you have a cost-effective design. Of course, you don't have to compromise your design with performance. So, in conclusion, that's what you do. So, make sure the design is made cost-effective. Then the design should be well protected. You don't want to burn someone's house. Then self-practice has to be done all the time. You need to avoid high sage loads if possible, and whatever appliance is not in use has to be switched off to save energy. So that's the presentation, and I would like to say thank you for your time, and I hope you've learned something.